Hello and welcome to another video by Emily Learning. In this video, we'll be looking at what is being tested in the chapter on heat capacity and latent heat for O-level physics. So let's get started. The best way to look at what is being tested for O-level physics is by looking at the O-level physics syllabus. So here we are at the O-level physics syllabus. Alright, so let's go through what is being tested. So in the first part, you are asked to be able to describe the rise in temperature of a body in terms of increase in thermal energy. So when there is an increase in temperature of a system of a fixed mass, okay, this means that the average kinetic energy of the system has increased. All right. Next, you need to know the definition of the terms heat capacity and specific heat capacity. So I have a post on the list of definitions that you need to know for physics. So here is the definition of heat capacity and specific heat capacity. Make sure that you memorize them. All right. So I'll provide a link in the description below on where you can um, access this list of definitions. All right. Okay, so you need to know the definition. So yes, we have it. Then next, recall and apply the relationship thermal energy equals to mass times specific heat capacity times change in temperature. So basically, Q equals to mc delta theta. So for the formulas that you need to know for this chapter, I've also summarized them here. So I also provide a link to the description below. So if you are interested to have the list of the formulas you need for O-level physics, do check out the link below. All right. So this is the formula. Q equals to mc delta theta. So change in thermal energy equals to mass times specific capacity times delta theta, which is the change in temperature. Okay, so you need to know this formula and you also need to be able to apply it. Okay, next, let's talk about melting, solidification, and boiling and condensation. So when something is going from a solid to a liquid, so solid to liquid, solid to liquid, this is called melting, right? And if it's going from a liquid to solid, it's called solidification, or we can also call it freezing. Okay. Okay, so if it is a pure substance during melting or during boiling, there is no change in temperature. Why is this so? This is because the heat energy that we are supplying is not used to increase the kinetic energy of the particles, but instead is used to overcome the attractive forces between the particles. So that is why during melting and boiling or during change in state, there is energy that is being pumped in. Okay, but there is no change in temperature because the energy is not used to increase or change the kinetic energy, but is instead used to change the potential energy or the to overcome the attractive forces between the particles. All right. Okay, so that's what this part is called talking about. Next, you need to be able to explain the differences between boiling and evaporation. So boiling occurs at a fixed temperature. So for example, the boiling point of water is 100 degrees Celsius under standard atmospheric pressure. But evaporation can take place at any temperature. So on a hot day, there'll be evaporation. On a cold day, there'll be evaporation, though there'll be lesser. Okay, boiling, it occurs throughout the liquid. Okay, but for evaporation, it only takes place at the surface of the liquid, because in evaporation, the particles or the liquid particles with a higher kinetic energy is able to escape, okay, from the liquid phase to the gaseous phase. Okay, so it only takes place at the surface of the liquid for evaporation. Okay, next, for boiling, right, the temperature remains constant throughout boiling. But for evaporation, when evaporation takes place, the particles with the higher kinetic energy will be lost, okay, to the gaseous state. So there is an overall decrease in the average kinetic energy of the liquid. So therefore, evaporation will result in cooling of the liquid. Next, you need to be able to define the term latent heat and specific latent heat. So here is the definition. Okay, so you need to remember the definition of specific latent heat of fusion. Uh, and latent heat of fusion. okay, as well as latent heat of vaporization and specific latent heat of vaporization. So memorize these definitions. Okay, I'll provide a link in the description below on where you can get these definitions. Okay, coming back to this, you need to apply the formula Q equals to mass times specific latent heat. Okay, so which is here. So Q equals to mL. L is the latent heat, M is the mass, Q is the change in the thermal energy. Okay, so this is the formula you need to know. Okay, so explain latent heat in terms of molecular behavior. So I have explained just now. So what happens when there is a change in the state? So for example, if I am going to heat a liquid, what happens is the energy that is supplied. Um, okay, so maybe what I'll do is I'll do H and L together. So let's draw the cooling curve. Okay, so I have a gas. Okay, okay. So this is temperature and this is time in minutes, for example. So I'm going to allow maybe a liquid to cool down. So you notice that there is two lines here. So this is when condensation takes place and this is when the freezing takes place. You notice that during condensation the temperature remains constant. This is because, right, the heat lost, okay, is not used to decrease the average kinetic energy but instead used to decrease the potential energy between the particles, okay, or to overcome, or yeah, um so because when this happens during the condensation, the particles here are going to have an increase in the attractive forces because you're going from a gas to liquid. So yeah, increase. So what is changing is the potential energy between the particles. Okay, same for here. Okay, so during a cooling curve, okay, during the change in phases, that means from gas to liquid or from liquid to solid, the temperature remains constant. Okay, because the energy that is lost is not used to decrease the average kinetic energy. Okay, instead it is used um, for the potential energy. Okay, it changes the potential energy. All right. So that's it for this chapter. So a lot, you notice that for the chapter on thermal physics, so that means it includes temperature, this chapter, which is heat capacity and latent heat, then plus the chapter on thermometer and kinetic model, there isn't much calculation. The only calculations, or most of the calculations, comes from this chapter, where you make use of the formula Q equals to mc delta theta and Q equals to ml. Okay, so that's it for the heat capacity and latent heat summary. So for other summaries, take a look at our other videos. So I'll see you then. Bye.